Good afternoon, everyone. Hope all is well and everyone is doing all right.
Good afternoon.
How's it going? How's it going? All right. Did anybody have any general questions or concerns before we get rolling? Anybody try any problems, get stuck? Everybody okay? Everybody straight? So we should be in chapter 7 today. All right, so don't forget, this is an 8-week course, and we are less than a month away from closing out. So I think the 18th, October 18th is our last day. So yeah, make sure you guys are on top of this stuff. There you go. Make sure you guys are on top of this stuff and you're knocking it out. If you have any questions, make sure you get with me so we can make sure you're straight. Every day is opportunity for questions. Every day is opportunity for questions. So you most definitely feel free to ask them. Here we go. And I don't know if you saw, but I sent the email out of some set office hours that I decided to post. You can always feel free to come to those. All I ask is that, if you do come to those office hours, make sure that you already have your questions established. Already know what problems you want to see me do and talk about versus just saying, I have a problem with 7.1. Well, that doesn't help me help you. So make sure if you have a problem with 7.1, go into MATLAB, pick out problems that you want me to do or walk through, and then that'll help us with at least having a direction of where to go with these problems and stuff. So, all right. So everybody's good. Everybody's straight before we get rolling. Just want to make sure. So now chapter 7 is on the 7.1 and 7.2. So we'll do those two class sections today. Chapter 8, trying to map this thing out so we'll be in a good place. So next class we'll do chapter 8. Then the class after that, make sure we're good. Yeah. So, hold on 1 second since we're here talking about this. So today's the 22nd. We do chapter 7, chapter 8, 8.182, then 29th. No, 2.1. 2.2. Okay. Yeah. Okay, just making sure some things. So mapping this out, of course, like I said, every day is opportunity for questions, but from this point forward, chapter 7 has 2 sections in it. Chapter 8 has 2 sections in it. And then chapter 10 has 2 sections in it. So we can do 2 sections per day moving forward. So today we do chapter 7. Monday we do chapter 8. And then Wednesday we can do chapter 10. And so that next week would be the first week in October. And we got room to play around with dates and days as well for reviews and all the stuff like that. So really, like I said, if you have questions, you don't even have to do a Zoom, extra outside Zoom day. You can bring them to class. We have plenty of time. So I'm looking at our final exam being on. Let me find a page to write. Yeah, I can find a good page to write on. Okay, here we go. So we're looking at our final exam day being on 10/13. That's a Wednesday. So now the reason why I did it on the 13th versus that Monday, this will be the last day of class as well. but that gives you the weekend to get all of your assignments in. So we do the final exam on the 13th, which is a Wednesday. And then everything should be due. And I need to make sure when I have to have final grades in. So we got Monday, the 18th. I should be able to leave and let final submissions be 10/18, which is a Monday. So that's for everything in Math Lab. Now, what I also can create is a final exam makeup. And that will also be due, on the 18th. And that's why I was saying we do the final exam on the 13th. And that'll give you time to finish up anything else you want to finish up in the class and take advantage of the final exam makeup. Wherein the highest grade you can get on that though is a 75. In all fairness to those who everybody has to take now I will say this, everybody has to take the final exam. So the final exam makeup is not a substitute for not taking the final exam proctor. Okay. So I just want to throw that out there. And I'm going to send you an email, with all the details and all the stuff like that. But I'm just throwing it out there, just planting the seed now so you guys can get, wrap your mind around the concept of what we're doing and trying to do. So everybody is required to take the final exam. You can't opt out of the final exam the first time and then just go do the makeup. So you have to take the final exam. And then what will happen is after the final exam is taken, the makeup will pop up. And so you take that and the highest grade you can get on is a 75. So in other words, if you get a 72 on the actual final exam the first time, I wouldn't worry about taking the makeup. Really, the makeup is for somebody who makes a D or less on the final exam. So, but that's just, like I said, just a buffer for anybody who make a bad grade on the final exam initially. All right. Questions on anything that I've said? We're going to revisit all of this information as we get closer to final exam day, but I know it's not that far away. So I'm just throwing it out there now while I was thinking about it. Everybody good? Everybody straight? Everybody straight? Okay. So once again, just giving you a heads up, we got 7-1, 7-2 to cover, 8-1, 8-2 to cover, and then 10-1, 10-2. And then we should be in a good place as far as content for the class. All right. So let's get to it. We're looking at 7.1, properties of normal distribution. So we have a probability distribution function, sometimes called PDF. It's an equation used to compute the probabilities of continuous random variables. Oh, properties of normal distribution, I didn't emphasize. Remember our normal distribution curve? Remember that bell-shaped curve? Remember I said that we were going to be using that as we progress forward. So that's about to pop up now. The usage of that more so is about to pop up now. All right, chapter 7, 8, and 10 depends on your, your usage of our bell-shaped curve. So it must satisfy the following two properties. The total area under the graph must equal to 1. So really that's this purple that I shaded here in the graph. All of that equals out to 1. And then the height of the graph must be greater than or equal to 0 for all possible values. Let's see, did I draw it anywhere else? No, I didn't. So just saying that, notice how I put a space right here that, hold on, was that what the part of that? Greater than equal to 0? Oh no, that's something else. But never mind, I forgot about that. That's something else. But your height of your graph must be greater than or equal to 0 for all possible values. And you're talking about, the height of this graph. So in other words, it can't be negative. So when we go to our percentages, you'll see that our percentages will never be negative. All right, scrolling up some. So a continuous random variable is normally distributed or has a normal probability distribution if its relative frequency histogram has the shape of the normal curve. All right, so that's the shape of the normal curve once again. We have inflection points, or what we call inflection points, at one standard deviation out. In other words, if you were to add a standard deviation to your mean, subtract a standard deviation from your mean, you have these inflection points, and that's just where the curvature of the graph changes. And I believe I explained it down here. Yep, a little further, but just from where it goes concave up to concave down. You know, concave up is like a U shape, concave down is upside down U. So when it changes the curvature, that's called an inflection point. Of course, if I scroll up too far, let me know. Okay, should be right there. All right, can you scroll up? All right. So properties of the normal density curve. So the normal curve is symmetric about the mean. So I believe we talked about that before. When we first talked about the normal curve, your mean is in the middle. 50% of your data is to the right of the mean. 50% of the data is to the left of the mean. So if it's symmetric about the mean, that means the mean is in the middle and it reflects. So whatever's going on the left side is going on the right side as well. Number two, the mean, median, and mode are equal and has a single peak or highest point at the mean. And number three, we already mentioned, has inflection points at your mean plus sigma, or mean plus your standard deviation, and your mean minus your standard deviation. All right. Area under the curve is equal to 1. So, you know, we have 50%, 50%, that's equal to 100% or just 1. So that means also if you were to split it up, let's say the mean, or not the mean, but the data value you have is on further to the right. Let's say 70% of the data is to the left of your mean, or not your mean, left of your data value. Then that means 30% is to the right of it. You know, like I said, everything's under that curve. All of your data is equal to 100% of your data. So, And we already mentioned that area to the right of the mean equals 1/2. Same goes for the left. Just put that stuff in writing.
Professor?
Yes.
So the inflection points have to equal 1 for it to work?
No, not necessarily. So when we say it's equal to 1, we're talking about all of the data
Okay.
under the curve. Yeah, so your inflection points would be based on whatever your mean and your standard deviations are. So let's say if your mean is 5 and your standard deviation is 0.2, I don't know. So 5.2 would be one inflection point, and then 4.8 would be the other inflection point. You know, you add a standard deviation to the mean and subtract. And so that would be your inflection points right there. Yeah. So, but equaling to 1, we're talking about all of the data. And once we look at our chart, you'll see where we're going with that as well. But we're talking about the data equals to 1.
All right. Thank you.
Mhm. All right, let's scroll. So number 6, it says as x increases, the graph approaches but never reaches the horizontal axis, which is 0. Same goes for x decreasing. So that's what I was alluding to earlier when I was talking about that space. Excuse me. Notice the space right here. There's a space between the top of the actual curve and then that horizontal line. Like if you were drawing it, it actually never touches that. It never gets to 0, but it gets as close as possible to it, but it never touches. So that's what we're talking about there. And that goes for the left side as well. Any questions? All right, scrolling up. So we talked about the empirical rule, but this is just saying that that is still holding true as one of the properties of normal distribution. Same 3 statements. Of course, let me know though if I'm going up too high. So approximately 68% of the area under the curve is within 1 standard deviation of the mean. Approximately 95% of the data under the curve is within 2 standard deviations of the mean. And then, let's go right down with 6. 99.7% of the area under the curve is within 3 standard deviations of the mean. All right, can I scroll up? Oh yeah, this is just the diagram that goes along with that. Remember our percentages stay the same, but then what changes is, just like I was mentioning to your classmate, you know, your mean and then your standard deviation. You know, the bottom numbers will be determined according to what your mean is and your standard deviation is. So once again, that diagram applies to the words that we just finished. And the sentences we just did or stated, in chapter 7. I mean, not chapter 7, but it's step 7. Property 7. Yeah, so it's 34%. Remember, the mean is in the middle and it reflects about the mean. 34%, 13.5, 2.35, and then 1.15. All right. Can I scroll up? Oh, I thought I had 8. Okay, it's only 7. I think I'm thinking about another class. All right, are we good to scroll up? All right, so hold on 1 second, guys. I'm gonna look at something. That's it for 7.2. 7.1, I mean, okay, got it. Okay, so let's look at this one. This process just, this problem is just re-emphasizing the empirical rule. Just reminding you how we did it. So we have the birth weights of full-term babies are normally distributed with mean of 3,400 and standard deviation of 505. So, like I said, just to reemphasize the empirical rule process, these percentages stay the same. So those don't change from the diagram that I gave, but the numbers at bottom will change according to the information that's given to you. So your mean is 3,400, that always go in the middle. Then you have the right side of your mean. That means I'm going to take the standard deviation and add it 3 times to get those 3 values. So you add 505, add 505 again, add 505 the 3rd time, and that'll give you those 3 numbers: 3905, 4410, and 4915. And then if you want the left side of the mean, you subtract. Hold on one second, share. Okay. Subtract the mean 3 different times. So subtracting 505 once gives you 2895. Subtract it again, gives you 2390. And then one more time, 1885. Any problems with the process? All right. And so, you can put them, let's say, to the right and to the left of your mean. And those would be those values. And that's how your empirical rule will be set up. And, according to the percentages, if you want to know what's the chance of, let's see what we're talking about again. The birth weight of a full-term baby. What's the chance of a baby being or weighing between 3,400 grams and 3,905? Then you can say 34%. So you can do, play with it like that. The different values and the different percentages according to the weights and the empirical rule that the empirical rule created. Questions on that? Make sure we're okay. All right, anybody still holding on to this? All right, another example or exercise that you may see in MATLAB, it says shade the region that represents the proportion of full-term babies who weigh more than 4410. So they would just give you a diagram, like maybe 4 diagrams, and choose A, B, C, or D as to which one represents more than 4410. And so that diagram will look like this. More than represents to the right of 4410. So that's why you would have 4410 and shade to the right. If it had said less than, then you would have been shading to the left. All right, any questions? Any questions? All right, are we good? All right, everybody finish with this before we go to the next thing. Oh, somebody said something. Okay, so good, cool. All right, so let's look at 7.2. So now we're looking at the applications of the normal distribution, and we want to look at standardizing a normal random variable. So we've actually done this already. Once again, they remember they introduced it, I think in chapter 3, z-scores. When you take your data value minus the mean divided by your standard deviation. All right. So notice I put up there, we need the chart from pages A11 and A12. That's in the appendix. Matter of fact, let me go ahead and pull it up. All right. Everybody good? So an example of z-score is 1.23. Z-scores are always rounded to 2 decimal places. So make sure you hold true to that when you do your calculations. By holding on to black, it's going to show you how to use the chart. So let's say if we're looking for 1.23 in the chart. So if you notice, when you look at it, and I'm going to pull it up so we can see it, the left column starts at negative 3.4 and it goes all the way to positive 3.4. Then on the top is all hundredths place. It goes from 0.00 to 0.09. So if I'm looking for 1.23, notice what I have here. I'm looking for 1.2 on this left column and then the 3 on that top row. So whatever this value is, that last value to the right, that's going to be what you're looking for in the top row. Everything before that is what you're looking for in that column. All right, can I shift screens? Everybody okay? All right, so let's look at that chart. So this is what it'll look like. Notice, where's my writing? Here we go. So notice negative 3.4. Now this is the negative sheet. This is A11. Yep, A11. Then the A12 is all positive values, and that ends in positive 3.4. Okay. And what I can do is send you a copy of this, even though you already have access to it in your book. I can send you a copy of this as well. Matter of fact, let me write myself a note. All right, so I'll send you guys a copy of that, of this. So 1.2, let me make it a little bigger. So 1.2 is right here, 3 right here, but 0.03 is right here. So that represents 1.23. And then you go over to where they meet. And that's 0.8907. All right, any questions on extracting values from the chart? All right. So that's how we got the 0.8907 right here. Now, also, if you look at that chart, it has this at the top left corner. And so you have your Z-score, and then it has this, everything shaded to the left. So that means the chart value will always represent what is to the left of the data value. In other words, less than. So it will always give you less than. So that means in order to get greater than or to the right of, then we have to do one extra step. But this chart value will always give you less than. Also, let me mention that every Z-score chart aren't, they give you the same values, but they're not created the same. So if you go Google Z-score charts, you may see something up there that may be different from this chart. So if you're going to lean on what I'm telling you in this class, then you have to use the chart that came along with this book. Once again, if you go Google, you can find 2 or 3 different types of charts out there for Z-scores, and the way you calculate your Z-score will be a little different than the way you calculate this one. But if you do it right, you still get the same answer, but you wouldn't be able to lean on the methods that I'm giving you with this one. So just throwing that out there just in case you go Google and Z-score charts. All right. And so in the green statement right here, that's the extra step that I was mentioning to find out what is to the right of the value. In other words, greater than, then you will subtract that chart value from 1. Chart value will always give you less than. If you want to know what's to the other side, remember that everything under the curve is equal to 0. So if you want to know what's to the right, you have to subtract it from 1. All right. Questions, questions, questions. All right, scroll up. Is everybody good with the green? All right. So a pediatrician obtains the heights of her 3-year-old female patients. The heights are approximately normally distributed with mean 38.72 inches and standard deviation of 3.17 inches. Determine the proportion of the 3-year-old females that have a height less than 35 inches. So I'll give you a chance to write that out. All right, so once again, the heights are normally distributed with a mean, and normally distributed is key because that allows us to use the bell-shaped curve. So normally distributed with a mean of 38.72 inches and standard deviation of 3.17 inches. So if we write down our givens, that's what I have here in red. And so our X value, our data value is always the value in question or the value we're challenging. Determine the proportion of 3-year-old females that have a height less than 35 inches. So we're trying to do our comparison to that 35 inches. So that's always going to be our X. Then we plug into our Z-score formula. So that's going to be 35 minus 38.72 divided by 3.17. And that's negative 1.17. So give you a chance to write that out. All right, so let's go to the chart once again. Just want to make sure we are okay with reading the chart. So we're looking at negative 1.17. So the first thing we do is go to negative 1.1, and we look at negative 1.17. So we look for negative 1.1 here, and then 7 here, and then we see where they meet. And that's going to be 0.1210. Any problems with that? All right. So that's what we have here, 0.1210. And so remember, we were looking for less than, and the chart value always give less than. So we're going to use the chart value. So the proportion of the pediatricians, 3-year-old females who are less than 35 inches tall is 0.1210. All right, is that okay? All right, next one, using the previous problem, find the probability that a randomly selected 3-year-old girl is taller than 37 inches. All right. So 38.72 is our mean. Standard deviation is 3.17. Data value that we are comparing to is 37 inches. Put that in the z-score formula. 37 minus 38.72 over 3.17. Go ahead and calculate that out. That'll be negative 0.54. All right. So go to the chart. So the negative 0.5 will be on the left column, 4 will be on the top row, and they will meet at 0.2946, 0.2946. All right, everybody good? So red statement, chart always gives less than. So to find greater than or taller than, in this case, we're looking at taller than, greater than. There'll be key phrases that are only gonna, tell you one of the two, either greater than or less than. So taller than is the same thing as greater than. We're gonna subtract that chart value from 1. So 1 minus 29.46 is gonna be 0.7054. All right, problems, any problems? So there are only 3 scenarios. So we've done 2 of them, got 1 more. So we did less than, we did greater than, and then the third scenario is between. So using the previous information, find the probability of randomly selecting a 3-year-old girl that is between 35 and 40 inches tall. And then I'll put it there inclusive. All right, so what we have to do is find a z-score for each one of those data values. So we have 35 and 40. We found the z-score for each one of them individually. Mean and standard deviation is the same. But for the first one, 35 minus 38.72 divided by 3.17 gives you negative 1.17. Then 40 minus 38.72 divided by 3.17 is 0.40. All right. Any questions? Any questions? Go to the chart for each one of them individually. and we get 0.1210 for negative 1.17, and then 0.6554 for 0.40. All right, everybody good. So just to give you a visual as to how why we're doing what we're doing. So if we got to remember every chart value we get, every value we get from the chart giving us less than or to the left of. And so, looking at your first z-score, that's to the left of that value. Your second z-score, which is furthest to the right, gives you what's to the left of that. That's why it's more. But I want to know what's between these two z-scores, which is right here. So the way I can do that is just subtract this from this, and that'll give me what's in the middle. So to find out what is between data values, you subtract the chart values. So notice I underline chart values. You don't subtract z-scores. You subtract the chart values. So you get your values from the chart, and then you subtract the chart values. Same thing with subtracting from one. You don't subtract your z-scores from one. You subtract the chart values from one. When we're talking about greater than, you subtract the chart values from one. So you're always doing work with the chart values. So here we go, between 6.55, well, 0.6554 minus 0.1210, that is 0.5340. All right, any problems, any problems? So summary of our scenarios. Here are our 3 scenarios. So less than, greater than, or between, only 3 scenarios that we're gonna have. If it's less than, or any phrase that suggests less than, what is it, shorter, colder, below, under, beneath, that is the chart value. You're gonna use that chart value that is given. If it's greater than, taller, hotter, above, something like that, then you want the values to the right of your data value. So you subtract that chart value from one, and then between the chart value, subtract the chart values from each other. All right, questions, questions, questions. Everybody good, everybody straight. All right. So with that being said, like I told you, as far as the rest of the class goes, we have to get to chapter 10. We at 7, we just did 7.1. There's only 2 sections in chapter 7, only 2 sections in chapter 8, and then, like I said, two sections in chapter 10. Um, and the only reason I'm making sure that we good with this, I don't know if you guys saw the video that I sent out. I don't know, who the student is or what class the student is in, but I do want to make sure, that we have understanding that if ever I let class out early is because I'm done with the lecture, not because I'm done with the class. And if anybody have any questions or want, to run over some problems or run through problems or whatever, the floor is open. But if no one has anything, and I don't want to continue to push further because, different things that, if you check the video, I explained, the different things that I consider, whether it be class, how heavy the content is, or where the class is as far as pace wise to closing out the class, or where students are in math lab, because I'm not just teaching one person, I'm teaching a classroom full of people. If everybody, majority of the class is not ready to move on, I try not to, overflow or overwhelm people with new content, new material, especially when you talk about math, when a lot of people, don't even really like math, but they're just dealing with it for right now. So I just want to make sure we have an understanding. Once again, I don't know who it is, so you don't have to feel any kind of way. I'm not mad, but I don't know exactly what your concern is, because you never brought it to my attention. So, I'm just trying to, just, shoot in the dark a little bit. But I do want to make sure people understand that, like right now, I know we're supposed to go further than 1:30, but I don't, you just got this. And I just want to give you the opportunity to do this. And looking at Math Lab, I know there's some people that are behind. Everybody's not behind, but there are some people that are behind that me continuing forward, like jumping into chapter 8 would not be beneficial when some people, haven't had a chance to even look at this chapter 7 stuff. And some people, still in chapter 5. So that's my thought process. That's my thing. But the room, and I don't want to lecture all the way to the end of class and then not give people opportunity to ask questions as well. So I try to have opportunity for everybody to ask questions every day. So that's why that is set up that way. With that being said, anybody have anything? Any questions, concerns, comments before we close? Yes.
Yes. I have a question. So
Yeah.
my computer been lagging. It was showing a whole bunch of pop-ups and was getting in the way of like some parts of the lesson. Is there a way you can upload maybe the video today for me?
Absolutely not. I'm not your genie. No, I'm just playing. Yeah, so I can go ahead and do that today. Yeah. All right. I know you were looking like,
I appreciate that. No, you. I know some people give you a hard time. I don't know why. You keep it smooth and look, don't get the opportunity. That's on them, but I'm good.
Okay. Well, I appreciate it. So yeah, I'll go ahead and because I got a few minutes, right now anyway to do that. So I'll do that right now for this class, and I'll make sure you get that.
And and the other thing, I know you said the 18th is when we close out, and the final. What was the day for the final that you were saying?
It's the 13th.
The 13th.
Yep, that should be the Wednesday.
How long do we have if we wanted to like wait a little bit? Is it still the 18th? Because I remember you were saying at the beginning of the class it was around December.
Oh, you said around December. Well, your class is an 8-week course. This class is an 8-week course. So now if something happens and you can't do the final on that day, then you have to get with me individually, and we can talk about arrangements that we can make to try to accommodate that situation. But that will be an individual case by case thing.
Yeah. Okay, that works. Thank you.
Yeah, not a problem.
I was just asking because I was taking I'm taking a whole lot of classes to get these prerequisites for nursing. So I was just
right. Yeah. If you come across the issue, if you can't get your stuff in by the 18th or something weird, something crazy, I know 8 weeks is quick. Shoot me that email and then we'll work it out, figure out what we can do to make sure that you get the grade that you're trying to get. Have a legitimate chance to get the grade that you're trying to get. Yeah.
Okay, thank you. I appreciate it.
Yeah, not a problem. Anything else? Anybody else? Everybody good? Everybody straight?
I did have a question. So far I'm good, but in the event that I do need help after hours for the, I believe it was scheduled office time. Is
Mhm.
that first come, first serve or by reservation?
No, just come through. I'll sit up there. I'll just have my Zoom on and just wait for somebody to come in. And now it is possible that more than one person could be in there because that's for all my classes. So, I would just alternate between different people answering questions and stuff like that. And yeah, but if office hours happen the same way it did face to face, I mean, it won't be that many people there.
All right.
Yeah, so yeah, you
Thank
can
you.
just come in. Yep, just use that link, click on it, and I should let you in. Yep, should be a problem. All right. Anything else? Anybody else? Everybody good? And also, when it comes to those office hours, if they don't fit your schedule, then shoot me that email, and then we can figure out what time that will fit both of our schedules. So that opportunity is always available as well. If we have to move it, or do another day, do another time. So, all right. So if you guys are good and I'm good, like I said, let's get on this work, man, because it's less than a month away. It's 9/22 today, and our last day is 10/18. So we want to make sure we stay on top of this work. Other than that, you guys have a good one. Be safe. And I'm gonna go ahead and work on posting these videos. So you guys take care.
You too. Enjoy the rest of your afternoon.
Thanks.
Take
You the
care.
same. Thanks. You the same. That's it. Take care. Bye-bye.